Now let us discuss the various types of load one by one. We'll start the classification of your loads. The first one, that is with respect to the time. So let us see, with respect to time, the loads are of your static type and your dynamic type. So the static loads are those whose magnitude and direction will remain constant with respect to time, right? The force is a vector quantity. So if I say that force is changing, right, that means either the magnitude of the force is changing or the direction of the force is changing, or both magnitude and direction of the force is changing. But if I say that force is constant, that means the force, magnitude and direction both are constant with respect to time. There should not be any change in the magnitude of the force and the direction of the force. So that type of loads are known as your static load. So static loads are of two types. We already see that. One is dead load and another one is gradually applied load. So dead loads are those constant weight loads which are applied on a body or on any beam or any structure, right? So dead loads are the constant weight loads, and example of the dead loads is weight of the bodies, right? If I say there is a body, this marker is having some weight, so if I put it on this hand, so the load acting on this hand because of the weight of this marker is the dead load, right? The weight of the non-living body acting on any beam or any structure is your dead load. So if I want to know what is the dead load variation with respect to time, so this is a load time graph. On y-axis we have load, on x-axis we have time. So the dead loads remain constant with respect to time. The load, let us say this load is P because of the dead weight. So this is the dead load variation of the static load, right? The second type of static load is your gradually applied load, and gradually applied load are those loads whose magnitude will gradually increase, right? This is the term of gradually increase from 0 to maximum, and in this increase of the magnitude of the force from 0 to maximum, the time will be more. The time taken by the force to reach from the 0 magnitude to the maximum magnitude is more. Then we can say that that type of load is your gradually applied load. So if I say that the load variation, this is the load variation diagram for the gradually applied load. So I am saying that initially when at time is 0, so the load magnitude is 0. So from 0 to A, the load is continuously increasing. 0 to A, the magnitude is increasing, but this increase is very slow with respect to time. That means the slope of this line is very, very less, right? So if I say that at the point A, load reaches at its maximum level or maximum magnitude value, so the load corresponding to point A is your P max, and after reaching your maximum magnitude, then the load magnitude will remain constant throughout the time. So this type of load is known as gradually applied load. So if I say that, let us say this is the change of the magnitude of the force. So let us say this is your point 1, this is your point 2. The change of magnitude of the load from point 1 to point 2 is delta P, and the time taken by the load to change from 1 to 2 is delta T. So this delta T should be very, very high, right? Then this type of load is known as your gradually applied load. If the slope of this line 0 to A, if the slope of this line is very high, very large, so that type of load is not a gradually applied load, right? If this line is more vertical, then the slope is more, so the magnitude of the force is changing with respect to time in very less time, in suddenly you can say. So that type of load is your impact load, not gradually applied load. So gradually applied load will be those load whose value of force is changing from 0 to the maximum level in more time, right? This is a gradual increase of the load. So this is the type of your static load, which is your dead load and your gradually applied load. The next classification is dynamic loads. The dynamic loads are of two types. One is your impact load and another one is your fatigue load, right? Dynamic loads are those loads whose magnitude or direction or both is changing with respect to time. With respect to time, either the magnitude of the force is changing or the direction of the force is changing, or both magnitude and direction of the force is changing. That type of load is known as your dynamic load. The first type of dynamic load is impact load. So impact loads are those loads which are acting for a very short interval of time. For a very small interval of time, these loads are acting, or you can say the magnitude of this load will change from 0 to the maximum level in a very less time. So if you want to draw the load versus time graph for the impact load, so it will be look like this. In impact loads, the value of the load will be changing from 0 to maximum level in very less time. The slope would be very large. Suppose this is the load versus time diagram. This is load and this is the time variation if you want to draw. Then if the slope is more vertical, like this, from 0 to A, that is the maximum level, maximum load. So in this, the time taken by the load to reach from 0 to maximum is very less. Only this time is taken by the load to reach from 0 to maximum. So that type of load is known as impact load. Impact loads are those loads which are acting for a very short interval of time. Suppose I am just applying load on this board in this direction. So this load is, the magnitude of this load is varying from 0 to maximum in no time, you can say. So this type of load which are acting for a short interval of time is known as impact load. For example, we have some IC engine components like your piston, connecting rod, crankshaft. So many components are there. So the loads acting on those piston or crankshaft or connecting rod are your impact load. Right, for a very short interval of time loads are acting. Or you can say any hammering action. In your manufacturing process, there are a lot of hammering action is involved. So that hammering action is a kind of impact load. So if you want to define whether the load is impact load or the load is your gradually applied load, right? If you want to differentiate between gradually applied load and impact load, we have some criteria. Let us say small t is the time of application of load. At what t is the amount of time at which your load is acting, and capital T is the time period of vibration, right? If I just apply load on this board, impact load or gradually applied load is I am applying load on this from 0 value to maximum value in a very large time. So we can say because of this load, the molecules in the board, the molecules which are in this board will start vibrating, right? If they are start vibrating, then the oscillation time period of oscillation means the time taken by the molecule to reach its initial position is the time period of the oscillation. This is the mean position of the molecule. If it start vibrating in this direction, so the time taken by the molecule to complete one oscillation is the time period of the oscillation. So I can say that capital T is the time period of vibration or time period of oscillations, and small t is the time of application of load. So if the time of load, time period of load or time of application of load is less than the half of the oscillation time, right? Means half of the oscillation times means this vibration is only completing half cycle. Then also again, right, you just apply a impact load on this molecule, it starts vibrating. When it completes its half cycle, in meantime you applied another impact load, so that is the case of your impact loads, right? When the time period of your or the time of application of load is less than the half of time period of oscillations, then this is kind of impact load. And if time of application of load is greater than the 3 times time period of vibration, then that type of load is known as gradually applied load, right? This is the criteria. And if the time of application of load is in between T/2 and 3T, then the nature of the load, whether it is impact or it is gradually applied, we don't know. For the same condition, we are saying that in this condition, if the time period is or time of application of load is greater than T/2 or less than 3T, then at that time we are assuming that it is a impact load. We are assuming for the worst situation, because impact loads is the worst type of load among gradually applied load and impact load, because of impact load, body will have a tendency to fail earlier rather than the gradually applied load, right? So this is the criteria to differentiate between your impact load and gradually applied load. Now, if I say that if on a body I applied some impact load, and because of that impact load some stress is developed in the body. The body is a deformable body, then stress will be developed in that body. So if we can say that the stress developed because of the impact load is your impact stress. So if you want to calculate the impact stress, we have this formula, that is impact stress, sigma is the symbol for stress, sigma impact will be equal to sigma static into impact factor, right? We will come to this derivation, we will derive this in our later lectures. Then impact stress will be equal to static stress into impact factor, and the value of impact factor will be 1 plus under root 2h upon delta static plus 1, right? This is the value of impact factor. In this, the h is the height from which the body is falling. Suppose I release this marker from here, so this is the height from the ground. When this marker hits the ground, it will apply a impact load on the ground. So this height from which the load is falling or any weight is falling, so if I say my hand is here and I am just applying load on this marker or on this board, so I can say that the distance between this board and my hand will be h. So h is the height by which your load is falling. And delta static is the static deflection which we can be obtained with the help of Sohm equation, right? In strength of material we have so many equations. For axial load or normal load we have some equation. For bending we have bending equation. For twisting we have torsion equation. All these equations which we have in the strength of material, all these equations are derived by assuming that the load is the gradually applied load, right? In strength of material we are assuming that any load which is applying on the body is gradually applied load. So by considering that gradually applied load, we have some equations which is known as Sohm equations. So if I write the Sohm equation here, so generally we have 3 equations. The one is your equation for the normal load, or in the case of normal stress. So if I say the normal stress will be equal to internal resisting force per unit area, this is the normal stress. And from Hooke's law we will discuss it later also in detail, but for your understanding how to calculate this sigma impact and sigma static, I am just deriving this. Then from the Hooke's law we will know that normal strain, stress upon strain will be equal to your Young's modulus of elasticity, and strain will be equal to deflection upon or change in dimension upon original dimension, right? This is the normal equation, normal stress equation. If I write bending equation, if you want to know what is the bending equation, we will derive it later on, but for your understanding, bending equation is m upon INA is equal to sigma b upon y is equal to E upon R. This is the bending equation. In this, we are saying in this normal stress equation, this internal resisting force which is acting, or the load which is acting, will be assumed as a gradually applied load, and in the bending equation, this m, that is this is bending moment, this is moment of inertia. This bending moment which we are applying on a body is gradually applied moment. We are assuming it as a gradually applied moment. So all the strength of material equations are derived by assuming that the load is static or the load is a gradually applied load. We are not considering in strength of material that the load is a dynamic load. We only focus on the gradually applied load. So if this is the y is the your distance from the neutral axis, we'll see. So from here, if you get this sigma b, this is sigma b is bending stress and this is the static bending stress, because this m we will treat is as a static load. Here also this sigma is the sigma static, right? When we are considering that this force which we are applying is the gradually applied load or the static load. So from the Sohm equations, if I write the torsion equation also, if I apply the torsion equation is T by J is equal to tau by R is equal to G theta by L. This is the torsion equation. In this also, this twisting moment which we are applying is the gradually applied twisting moment, and for this the shear stress which is coming will be the static shear stress. So Sohm equations are available with us for the static load. So with the help of Sohm equation, you will be able to find this delta static, that is the static deflection because of a static load in the Sohm equation, right? So delta static is the static deflection by the Sohm equation. You will get that delta static with the help of your Sohm equations. We'll see what is the Sohm equations in later discussions. So this is how you will calculate the impact shear stress or impact stress, which is equal to static stress into impact factor, and impact factor is 1 plus under root 2h upon delta static plus 1, right? So this impact load is a function of velocity, right? Is a function of velocity. Suppose if I am saying, suppose this is my hand and I am just allow this marker to fall from this height. So this marker has some potential energy. When I leave this, so it will strike this hand with some velocity. So the force which this marker is applied on this hand is a function of this velocity. If I increase this height up to this level, and now if I throw it, if I fall it, then the velocity at which this marker is striking on my hand is more, because it has some more potential energy. So the impact load this marker is striking on the hand is more. So if you increase the velocity of the object which is applying the impact load, then the impact load magnitude will increase. Suppose this is the board. If I am applying the impact load with very less velocity, if I am applying, and if I apply the impact load with a very large velocity, with a very high velocity, then with this high velocity, if I strike this board with a very high velocity, then the impact load acting on this board will be more. So impact load is a function of velocity. If you increase the velocity, the magnitude of a impact load will increase, right? Now suppose in GATE there are lot of chances that they may ask a question from the impact load, that a impact load is acting on a body, calculate your stress or deflection or anything. How to approach for that type of numericals? So for a problem, if any impact load is given, these are the steps how to solve the numerical of strength of material based on your impact loading. So for a problem, first of all, assume that impact load as a static load. If I am saying that on this board I am applying a 10 Newton of impact load, then for solving the numerical I am considering that this impact load will be as a static load. So I am saying that on this board I am applying 10 Newton of static load, right? So first step is to assume impact load as a static load. So by assuming it as a static load, we have to find the delta static from the SOM equations. We have to find the delta static from these SOM equations by considering the impact moment as a static moment, or impact stress as a static stress or static load. If I calculate this delta static, then the next step is to find impact factor. Impact factor is finding from this equation, H is known to you, then delta static is calculated earlier, so impact factor will be coming. Now after impact factor you have to calculate the sigma static, that is static stress, with the help of these SOM equations. With the help of these SOM equation you will be able to calculate these static stress, and if this sigma static is known, impact factor is known, put up in this formula, then from this formula you will get the impact stress. Similarly, if you want to calculate what is the deformation in the body because of impact loading, the same formula is valid, just from in the stress term you just put your deflection terms. So if you want to find what is the deformation due to impact loading, this will be equal to the deformation when your impact load will be treated as a static load multiplied by impact factor. So if there is any other parameters which you want to calculate for the impact loading, so any parameter for the impact loading will be equal to, just assume that impact loading as a static loading, so any parameter for a static loading into the impact factor. This is how you can solve the numerical of your impact loading, right?